Hello, good morning. Am I audible?
Yes,
Okay. So the answer for this question is, I guess, 8. Yes or no?
yes,
8, 16, 8, and 8. Yes or no?
yes,
Same for this 8, 16, 8, and 8. Okay.
yes,
So basically, in case of A, B, C, D, there are four chiral center, correct? So if there is four chiral center and molecule is dissymmetric, then total number of stereoisomer will be 2 to the power n. Yes or no?
yes,
So total isomer will be 2 to the power 4, that is 16. And obviously, because of this symmetry, all will be optically active. Yes or no? So the geometrical will be 8, total will be 16, and 8 pair of an enantiomer, and total fractions will be obtained 8. And this is also dissymmetric molecule. There is no chance of symmetry because A and B are opposite, A and C are opposite. So there is no chance of center of symmetry, as well as there is no chance of plane of symmetry. If we cut from this, then A to A, but B to C, like this. So there is no chance of. So we can directly say this answer. Yes or no? In
yes,
this case, we need not to draw any structure. Is this clear?
yes,
Okay. Now tell me one more question. CS3, CH, double bond CH, C double bond CH, CS3, CH, double bond CH, CS3. How many geometrical isomer are possible? How many geometrical isomers are possible for this molecule?
Sir, I see answer 4.
Yes, correct answer is 4. Could you please explain it?
Okay, so we have this one case where, just wait.
Okay.
Anyways, we have this one case where if we like assign such that in both of the top double bonds, the CH3 is like opposite to a carbon atom, then both of them will correspond to the same group, anti.
Yes, yes, correct.
Then in another case, we have one case where both of them are like in some sort of syn position. So both of them are still correspond to same group.
Yes, you are correct.
And then when one is syn and one is anti, then Gi exists around this downwards double bond.
Perfect. Yes. Check this one. Right now, this molecule is cis. Yes or no? This pi bond is cis.
Yes.
And this is also cis because both hydrogen are in same sign. Correct? If this is cis and cis, this will be same valencies. So it will not show GI. Correct?
Yes.
If this double bond is having both valencies exactly same, then on switching there is no stereochemistry change. So when both are cis, both will be identical. So both are same valency. So this double bond will not show geometrical isomery. So when both are cis, only one possibility is there. Correct? But when both are trans, if both are trans, then also CH3, correct? CH3. Now both are trans. Then also only one possibility because again both valencies are same. Yes or no?
Yes.
But if this one is cis and this one is trans, now we can clearly see both valencies are different. Now both are not mirror image to each other. This is cis, this is trans. Now it will show geometrical isomery, correct? So we will get two structure. Now this molecule is symmetric. Yes or no? So this trans and cis or this cis, this trans, both will be identical. Yes or no? So total geometrical isomers are four. Is there any doubt in this?
No.
Next, how many stereoisomers? How many stereoisomers are possible for this molecule? How many stereoisomers are possible for this one? You can try for this molecule also. This first, this is second. This is third. This is fourth. This is fifth. Number of stereoisomers are possible. Just solve these six questions. Total stereoisomers. What is answer of first question?
$32.
So you are calculating 1, 2, 3, 4, and 5, correct?
Yes.
These are stereogenic center.
Yes.
But answer will be 2 to the power 6.
Oh, yes, the double bond.
This double bond. Okay.
Right.
There is one liner, very important one liner. Up to 7 membered, up to 7 membered cycloalkene will not show GI at double bond. Okay. But 8, 9, 10 membered rings can show GI at double bond, and this form will be more stable than transform. Okay. Is this clear to everyone?
Yes.
So this molecule is dissymmetric. Okay. And if molecule is dissymmetric, then total number of stereoisomers are 2 to the power n, where n is stereogenic center, the centers where molecule is showing optical isomerism or geometrical isomerism. So this is chiral center, this is chiral center, this is double bond of 8 membered ring, this is chiral center, this is double bond which is showing GI, this is double bond which is showing GI. So answer will be 2 to the power 6. Is there any doubt in this? Okay. Is this clear to everyone?
Yes, sir.
Yes.
Okay. Now, what about second question? This is symmetric molecule. So there are three formulas. If molecule is dissymmetric, then 2 to the power 10. If molecule is symmetric, but stereogenic centers are odd in number, sorry, even in number, then this. And if odd in number, then this or this. Okay. For odd, two formulas are there. This is when dissymmetric. This is when symmetric, but an even number. This is symmetric when an odd. This is symmetric when an odd. Can you tell me symmetric and n is odd, but we are having two formulas? Why we are having two formulas? See, this one is symmetric. This is showing GI, this is showing GI, this is showing GI. This is symmetric molecule. Okay?
So and optically active.
No, no, no. I will use these two formula in different question. Okay. So just listen it carefully. Okay. This molecule is symmetric or dissymmetric? This molecule. There is no chance of symmetry, correct? Because here methyl, here is ethyl, but this group is same. Yes or no? But for symmetry, these two groups should be same, at least. Okay. Now, this pi bond is showing Gi, this pi bond is showing Gi, this pi bond is showing Gi, this pi bond is showing Gi. And always remember biphenyl, biphenyl, and one ring is having different valency, and its both valencies should be different. Then this also shows optical isomerism. Yes or no? So the answer will be 2 to the power 5 in this case. This is a trop isomer. If we are having biphenyl, okay, and both valencies are different, yes, this is different, and these are different. Okay, so it will show optical isomerism at this point, at the junction of two rings. Okay, so 1, 2, 3, 4, 5. Answer will be 2 to the 5. Is this understood to everyone?
Yes.
Okay. Now, we can take one more example like this. This is chiral center, this is chiral center, and this is chiral center. And there is no chance of symmetry. So 2 to the power 3. So here answer will be 8. So just note down these three questions and the explanation. If molecule is dissymmetric and there is no chance of symmetry, then total stereoisomers will be 2 to the power n, where n is either chiral center and double bond, which are showing geometrical isomer. Just note down these three questions. Completed?
1 minute. Yes.
Okay. Do you know the difference between these two formulas? When I will use this formula or when I will use this? What is the difference in this? Okay. See, this is first formula, this is second, this is third. Okay. And this fourth formula is star mark. This is only used when there is pseudo chiral center or pseudo stereogenic center. Pseudo stereogenic center, what is the mean by pseudo stereogenic center? Which is in reality is not chiral center or stereo center at all the time, but sometimes it can act as a chiral center or stereo center. Just listen it carefully. Now, this this will show always cis and trans, irrespective of the structure of this group. Yes or no? Because this pi bond is always showing geometrical isomerism. Yes or no? This pi bond is always showing geometrical isomerism, irrespective of the arrangement or structure of any other form. But see clearly, this is pseudo chiral center because when both are cis, this will be non-chiral center. But if it is cis and this is trans, then it will act as a chiral center. Are you getting my point? So if we have situation like this, that molecule is symmetric, yes or no? This can have symmetry. And if both are cis, this is not a chiral center. But if both are different, then this will be chiral center. So in such cases, we use formula 2 to the power n minus 1. And here n is chiral center, including pseudo center. So we will have 1, 2, 3. Including pseudo center, how many centers are there? 3. So 2 to the power 3 minus 1. So answer will be 4. So when I will use this fourth formula, whenever pseudo centers are there, okay? But in this case, all these pi bonds will show geometrical isomerism irrespective of the arrangement or structure of any other group. Yes or no? Then this is odd, free chiral center, free stereo center, molecule is symmetric, then we will use this one. Are you getting my point? 2 to the power 3 minus 1 plus 2 to the power 3 minus 1 by 2, 2 to the power 2 plus 2 to the power 1, so answer will be 6. Got it? Understood the difference?
Yes.
This is always chiral, this is always chiral, and again, the chirality of this center will depend on the structure of this. Yes or no? So this is pseudo chiral. So if we have pseudo chiral, then 2 to the power n minus 1, and including pseudo, so 2 to the power 2 answer. So these 1, 2, 3 are very famous for JEE Advanced, but nowadays JEE is asking question in which pseudo center is there. So formula will be different. Understood?
Yes.
Now attempt these four questions. What is answer for first one?
10.
Four chiral center molecule is symmetric. 2 to the power 4 minus 1 plus 2 to the power 4 by 2 minus 1. 2 to the power 3 plus 2 to the power 2 minus 1 2. So answer will be 10, correct? Again, four chiral center are permanent, but one is pseudo, and molecule is symmetric. So 2 to the power 5 minus 1. So this will be 2 to the power 4, 16. Understood?
Yes.
So this molecule is symmetric or asymmetric? There is no chance of symmetry. Yes or no? If
Yes.
you put mirror like this, 2 Cl and 1 Cl, 1 Cl. So this is dissymmetric. 1, 2, 3, and 4. So answer will be 2 to the power. Now tell me this is symmetric or dissymmetric? Again, this is dissymmetric. If we will put mirror like this, then Cl mirror image should be Cl. Yes or no? Here the mirror image of Cl is Br, mirror image of Br is Cl. So this is also dissymmetric molecule. Understood? Again 16. Got it?
Yes.
Okay. Now next question. Stability of pi bond. What will be the order of stability of pi bond? X, Y, Z, W. See, this one is trans structure. Yes or no? X. This is cis.
Sir, is the answer W greater than Z greater, sorry, W greater than Y greater than Z greater than X?
Yeah. This is trans. This is cis. Yes or no? Why it is trans? Because hydrogen will be like this. Okay. Here hydrogen will be like this. So this is cis structure. Here hydrogen will be like this, and hydrogen will be like this. Okay. Understood? So both Y, W and Y are cis. Okay. Is this okay? Hello. Hello.
Yes.
Yes, sir.
Yes or no? Because in 10-membered alkene, these are two isomers. This is trans form and this is cis form. Yes or no? But cis is more stable than trans. Got it? So now tell me what is your answer? Actually, cis, this one should be here. This is also cis. This is Y. Yes or no?
Yes.
Now, which one will be more stable in W and Y? Definitely W, because this is having resonance, double, single, double. Yes or no?
But sir,
So,
even Y is also under conjugation with X.
yes, so idea is one will be in conjugation and one will not be in conjugation. So I'm trying to, okay, cis form is more stable than trans. Okay, and there should be one difference. Otherwise, it will be safe. If we put here, then it is in conjugation with this. If we put here, then it will be conjugation with this. Here we cannot put. Okay, so in reality, we cannot comment on this. Yes or no? Okay.
Yes.
So basically, idea is which one it says, which one is trans. Okay. So we can do here identify cis trans of pi bonds. Okay. So W is cis, Y is cis, Z is trans, and W is uh, X is trans. You just note down this one. And obviously, cis is more stable than trans. But if both are cis, then we will check whether it is having conjugation or alpha H. Okay. Then normal pi bond stability order will be there. Okay.
Yes.
So cis is more stable than trans. this is the mixture of 8 carbonyl compound. Okay, this is the mixture of 8 carbonyl compounds, and in this mixture, excess of NH2OH is added. Okay, we already know if carbonyl compound on reaction with NH2OH, oxime is the product. Yes or no? We know this thing.
Yes.
Correct? So now the question is, if NH2OH is in excess, then how many total oximes are possible in on addition of NH2OH in this mixture? So we know this fact. This carbonyl is symmetric or dissymmetric.
Symmetric.
So only one oxime. Yes or no? Because it will not show geometrical isomer because both bonds are same, correct? But if this is dissymmetric, correct, then we will have two oximes. Understood, better?
Yes.
Okay. So this is the concept. Symmetrical carbonyl will give only one oxime. Dissymmetrical carbonyl will give more than one oxime. So this is the concept. Now you apply this concept in this question. Understood the question?
Yes.
What will be answer?
15.
15.
Yes.
This will give 2.
Yes.
This will give 2.
Yes.
This will give 1. This 2. This 2. This 2. This 1.
Yes.
Correct?
Yes.
This is 3.
Yes.
How this is 3? Because it will react on 3. That's why you are counting 3.
All right.
No, but it is in excess. So automatically it will react in all 3. But how you are saying that this will have 3 structure?
No, no, no. I'm saying that one will like react with one structure we'll have by one more reacting with
No,
one.
no, no. If it is in excess, then uh, we will react at all position.
Okay. Okay.
That's why I have written here excess NH2. It means you are counting that in one molecule only one CO will react, and in one two CO will react, and in one all three CO will react. This will not be the case because all three will react simultaneously. So in excess of NH2, we will not get any oxime in which one is reacted and two are non-reacted, because this is the reason for writing here excess of NH2. Okay. So what should be the answer here? So in these 7 molecules, we will get 12 oxime, correct? Is this okay? Hello.
Yes.
And for this, we will get this molecule. Okay. Now the question is, how many geometrical isomer are possible for this formula? So the real question is this: how many geometrical isomers are possible for this formula? How we will calculate this? Hello. Hello. Am I
Yes,
audible?
yes, yes.
So how many geometrical isomers are possible for this? This is the real question.
4.
What is explanation for this?
Because pseudo chiral center, pseudo stereo center.
Come again.
So,
You
pseudo
are not
stereo
audible.
center is 2 raised to 3 minus so on.
So you are saying that these chiral, this is, yes, this is symmetric molecule, and yes, because all three are pseudo. Yes or no? So this can have four structure. See, in one arrangement, this OH and this OH can be in different site. Yes or no? There can be one case where this group is different with this group, correct? It should not be mirror image. So there can be one case. Same, this can be one case. This and this can be different. So all three are pseudo and molecular symmetric. And yes, these three can show geometrical isomerism in any particular case. So the maximum possibility will be 4. So your answer will be 16. Understood? I am saying this is pseudo center. This is also pseudo, this is also pseudo. If we are having 3 pseudo center or 3 center including pseudo, then formula is 2 to the power n minus 1. Understood?
Yes.
And this question is, I think, asked in JEE Advance also. Same framing. So you just believe in the formula and process. Okay, in a cyclic structure or cyclic, such type of cyclic structure, we can get such type of answer. Okay.
Yes.
Actually, C double bond C, single bond C, double bond N, OH. Okay. Next. How many stereoisomers are possible? This is the question. What will be the answer?
32.
32. This is chiral center. This is also chiral center. This is chiral center. This is chiral center. This is also one of the center. And this is also chiral center. This is also chiral center. Am I right?
Yes.
So 1, 2, 3, 4, 5, 6, 7. Then what will be the answer?
Sir, but the chiral centers at the bridge carbons won't be like they only have two possible positions, right?
So answer will be 2 to the power 6. Or you are saying 2 to the power 5.
No, sorry, it's 2 to the power 6.
Yes. So always remember, if chiral center, if two chiral centers are there and both are bridged carbon, then what will happen? We cannot switch independently. Suppose if I switched at here, automatically it will switch at here. Yes or no? Suppose suppose this is the ring, okay? Okay. And we are having one bridge here. Okay. So it is not possible that the upward valency come downward and here upward is on upward only. What will happen if I will switch here? Automatically it will switch here. Yes or no? And the different valency will be like this. So the whole bridge will come downward. Understood? So whenever, got it? So whenever we are having two chiral center at one bridge, this right now this is upward. Yes or no? This will be like this. Okay. Hello.
Yes.
Now, what is possibility? If I will switch here, if this valency will go inside the plane, then automatically this will go inside the plane. Yes or no? Hello.
Yes. Yes.
Suppose this is the case, okay? This is chiral center, this is also. Now what will happen? Okay. This will be like this. Both valency will come downward, both valency will be upward. Correct? So if there are two chiral center at one bridge, we will count only one stereogenic center, correct? So See, the chiral centers are 7. If it is asked number of chiral centers, number of chiral centers 7, but number of stereoisomers will be 2 to the power 6 only. Understood this? Hello.
Yes.
Okay. Tell me number of stereoisomers in this. This is the structure. This is deuterium.
Sir,
Yes.
sir, that carbon atoms, well, what is it attached to?
In this
Yes.
C double bond C, this is double bond, this is also double bond. This is hydrogen, this is deuterium, this is hydrogen.
Okay.
Is it visible to everyone?
Yes.
Okay.
Sir, is the answer 2 raised to the power of 8?
1, 2, 3, 4, 5, 6, 7, 8. Yes. Please explain it.
Okay, so stereo centers 1 and 2 are the double bond at the bottom and the chiral carbon attached to the ring. Then
This is 1, this is 2,
yes,
and this is 3.
3. Then another one is at the top, 4, and the 2 OH.
5 and 6.
Then towards the left, we have the seventh one on the ring and the eighth
Yeah.
one in the diene thing.
Next is this allele.
Yes.
Oh, perfect. 2 to the power 8. Understood, everyone?
Yes.
Okay. I think you must be knowing this fact. If this distance is L1 and this distance is L2. Yes or no? The relation in L1 and L2.
L1 is equal to L2.
Yes. Positive, negative, positive, negative. Okay. So these two valencies will be perpendicular to these two valencies. So basically, if two A and B are in plane of board, then this will be perpendicular. Got it? So A, see, like this. A is this and B is this. Okay. And here A and B are like this. So if we compare with this valency, this distance or this distance, both will be equal, correct? Hello. Understood? So this will be optically active molecule. This is also optically active because if you can visualize this structure, this will be like this. C11C, if these are in plane of board, then this will be A outside and B will be inside. Now it will not have COS, it will not have POS, it is optically active, so its mirror image will be a different compound. Got it?
Yes.
Like this. If it is D, then definitely it will be A. Okay? So optical isomerism can be observed even if chiral center is not present. Correct? Understood this fact?
Yes.
This is something like heteroisomer also. Yes or no? If these two valency are different and these two valency are different, important is these two valency and these two. So what will happen? This will rotate perpendicular. So no POS, no COS. So this will be optical. Okay, got it?
Yes.
And if there is optically active substance, then its mirror image will be different. So if this ring is in plane of board, so this will be AB, and this is perpendicular. Okay, this ring is perpendicular. Okay, so here B, here. Now this will be like this. One ring is like this, and another ring is like this. Correct? its mirror image will be different. Got it? Hello.
Yes.
So these are few cases where chiral center is not present, but still these are showing geometrical isomers. Okay.
Yes.
Now there is one homework for you. Actually, that is not in JEE's scope. Okay. So we will not take in class, but I think in coming years, as per my understanding, it will be asked in JEE someday. So maybe next year also. So what is the question? Now listen carefully. I will let you know from where you can check such type of question. Okay, so we know if we have any chiral center. Okay, so we can easily calculate R and S. Yes or no? If there is one chiral center, we can uh, tell whether it is a R or capital S. Correct? Is this okay? For every chiral center, we can tell R or S. Correct?
Yes.
Hello. Do you know R and S? It is a representation for chiral center.
The absolute configurations.
Yeah, RS configuration. So if any molecule is having four chiral center, then there will be four RS configuration. Whether all can be R, all can be S, three can be R, three can be S, two can be R, two can be S. Yes or no? Is this okay?
Yes.
Okay. So what will be its configuration? Like this is F, this is Cl, this is Br, and this is N. Okay. And we know this is treating as a chiral center, correct? Because its mirror image will be a different compound. Are you getting me? Its mirror image will be different.
Yes.
So if this is R, then its mirror image will be S. Now, how you will calculate R and S of such molecules in which chiral center is not given? Got it?
No.
Let's say this is the given instruction. F and Cl are in the plane of board. Br is inside the plane and I is outside the plane. So the simple homework is R or S. Okay. So you just work out in this. We will continue in next class from here. In fact, you can message me. I can send you some links in which you can get. Okay. But I will suggest first you think about this because this is work. This can be treated as a chiral center. So if this can be treated as a chiral center, then what will be the nomenclature of this? Understood? So this is the exact molecule. We have to tell it is R or S, or we cannot comment anything on this. Got it?
Yes.
So just note down this molecule. And you just think about this. You just Google it. You can ask to a friend. You can check in book. whatever you want to do, you just do. Okay? Okay, thank you. Then we will continue in next class.